to prep for this thing. This is find the divisibility array of a string. Shout out to all my 7 followers out there who religiously watch my videos. I apologize for the amount of time that has transpired between my last upload and this upload. Work, life, relationships, society, socialization. These are all factors that contribute to my inability to post regularly. But I intend to mitigate that at this very moment and return to regularly scheduled programming. So with that, let's go ahead and get right into the problem. So you're given a 0 index string word of length n, and it consists of digits and a positive integer m. Okay? The divisibility array div of word is an integer array of length n such that div of I equals 1 if the numeric value of word 0 to I is divisible by m, or div of I equals 0 otherwise. So the basic idea, right, is we're going to look at a word like this, and we're going to look at each individual characters and determine if it's divisible by 9. So we'll look at 9 alone and make a determination if it's divisible by m. In this example, m equals 3. And since 9 mod 3 equals 0, then we'll have this return array answer, which will populate with the 1. Then the next example we'll look at is 99. And if we mod that by 3, it's also 0. So the next thing you populate is a 1. And I'm not gonna put commas here just so that it's, in line. So this 9 corresponds here. Then you look at 998 next, and you determine if it's divisible by m, which is 3, and it is not, right? Because 998 is not divisible by 3, so this is a 0. Then you look at 9982 and decide if it's divisible by 3. If you did that calculation, it is not, so another 0. Another 0. It turns out the next one is, the next one is, isn't. So that's the general idea of this problem, right? So you just look at the number that you're currently tracing and then determine if it's divisible by the m value that's given. Now, I think the most intuitive, obvious approach going forward would be, well, if you're looking at any individual, number, well, you don't need to recount. Like we can use the information from the previous iteration to solve the next iteration, right? So I can use the information from 9, meaning that all I need to do is just append in a 9, right? And then I solve this, and then I append in an 8, right? And then I solve this, and then I append in a 2. What I'm basically saying is we have like this running sum idea, right? What I don't want to do is solve for 9, and then forget everything I've done and solve for 99, then forget everything I've done and solve for 998, forget everything I've done and solve for 9982, right? The intuitive approach would be solve for 9, figure out your answer, and then add in this 9 and solve for that, and continue through like that, right? Because we actually have like a running sum, prefix sum notion already built into this problem because we're solving the div value from word 0 up to I. So if we just keep track of everything from 0 up to I as we go, then we don't need to recalculate anything, right? So what I'm basically saying is we'll keep track of like what our current sum is, right? And then we'll update it as we go through the system, right? So we'll solve for one thing and then we'll update it. So we'll have an answer array, which will be what we return. And it'll be empty at the beginning. And a current value, which is the current value up to word of I, right? So the current value going up. So what we really need to do, and it's something that you should probably know how to do if we're dealing with a medium problem, is how do we, convert strings to integers efficiently, right? How do we append in an additional character? Well, if you wanted to get, right, because in this system, for this first example, we're going to be looking at 9, 9, then 8, then 2, then 4, then 4, then 3, then 5, then 3. So if we wanted to convert this thing into a number, right, because these are strings, we take the current equals 9 at the beginning. And then at the next iteration, our current would be 99. So you take current equals 10 times whatever the previous current is, plus in the new character, 8. And the way that that works is, well, what we're basically doing is when we add in an additional character, we shift things over one to the left so we can add in that new thing, right? This is 9. And then when we get 99, we can do 90. So we can take 9, multiply it by 10, and then add in this 9. Right? To get 99. And then when we get to 8, we can multiply it by 10 to get 990. And then we can add in the 8 to get 998. So this is just a simple approach of taking a sum and turning it into a taking characters, which are numbers, and converting them into a number. Okay, sorry, it's been a while since I made a video, so I'm a little rusty. It's interesting. So what we can do is we can look at, just to show you how that works, we can look at each number in Word. Now we're going to convert the word into an integer, right? The individual letter in each word into an integer. And if we wanted to update C, we'd say C equals C times 10 plus N. And then just to show you how this works, we'll print out C. We're going to return 0, or an empty list. It's not going to give us the right answer, right? Because we're just trying to do some kind of debugging to show you how the system works, right? So you'll see here at the first iteration, it's 9, then 99, then 998, 9,982, 99,824, and so on and so forth. So you'll notice that these are the problems that you're looking at for each of the iterations, right? This is the first possible word of I, right? Because this is from 0 to 0. This is from 0 to 1, 0 to 2, 0 to 3, 0 to 4, so on and so forth. So now we have each of the individual numbers we need to process. Now, that will give us each of these individual words 0 to I. So then we just need to populate answer based on whether or not it works, right? So if it works, that would mean that the C value, which is like your running sum, your prefix sum, is divisible by M. If it's divisible by M and it equals 0, so that means that it's divisible, right? The modular arithmetic, it should be something that you understand if you're approaching this problem. But essentially it just means if something is divisible by something else, that means the mod of that thing is 0. Okay? And then at the end, we just return answer. Right, so since we're keeping a running sum up to 9 at the beginning, we can populate whatever the running is, sum up is to 9. And then since we keep track of the running sum up to 99, then we can calculate that. So intuitively, it makes sense since we're like doing everything from 0 to I for each I in the whole system. We might as well solve one problem, use that information to solve the next problem so we can do it efficiently. So if we submit this, we're going to get a time limit exception. And you might ask yourself why that is the case. The issue is, right, that there is something interesting that people don't usually think about when they're talking about the runtime complexity of their function, right? Which is, you may look at this and say, well, it's O of n time, right? Let's look at space and time, right? So let's look at n equals the length of word, right? We could say, well, it's O of n time because, well, I have to look at all n characters in Word and then do 2 constant operations, right? So that would mean that I'm doing big O of n operations, right? And then in terms of space, well, I have to create this answer array, and that has answer space, right? So there's n characters, so then there's n indices that I have to create an answer that I return. So you say, this is O of n time. Why is this failing? Why am I getting a time limit exceeded exception? Well, the thing is that people don't think about is, well, this isn't actually constant, right? Because I have to do an operation here, right? So that's going to be a log n operation, right? And then this is going to be a log n operation. Well, no, this will be a constant operation to append, but to actually, appending would be a constant operation, but modding it by m, if m is really big, that's a division operation, so that's another log n operations, right? So I'm going to get log of m operations every time I do something, right? This multiplies up to n. So in order to keep this maintained within the system, since we're dealing with modular arithmetic, right, it doesn't matter what the value is. It just matters what the value is with respect to m, right? Since we're doing divisibility, right, we don't care what the value is. We just care about what that value's result is when you divide it by m. So what you can do instead is say, well, since we're always modularizing this number by m to check if it equals 0, we can just do that here, right? And if that doesn't make sense, you know, this is kind of a property of modular arithmetic, right? I can mod something twice and get the same result. So if I mod it here, I can keep the value small. I can keep the value tethered by m. That way, when I do these operations, they're more efficient, right? So now the value doesn't blow up too quickly, right? Because the value can very easily become very large. Okay. So then now you don't even need to check here. You can just say check that c equals 0. And just like that, it's going to fix your runtime lickety split. Lickety split, split, lickety. Okay, so what's the runtime of this then? Modding something by m. So space is the same, right? Because answer will have n characters, and the characters are either 0 or 1, right? So it doesn't scale with anything but n. It's some constant value times n indices. For time, well, we have to look at all n characters, so that's going to take n time. And then we have to do an operation dividing by m to determine the modular arithmetic. So that's log m, right? If you have n values, if you have a value of n, it requires log of n bits in order to represent that value. So you have to do log of n operations to calculate that value. So for time, it's O of n log of n. All right. Versus before what? I don't know. Okay, guys, peace out. Right, because now the value that you're calculating on can't be larger than m, right? And versus before, the value could be as large as n or m, so n squared, barely too slow. I don't know. All right, guys, that's it for today. I'm a bit rusty. Hopefully tomorrow I'm a little better at articulating my points.